Alright, welcome to another quick video on some physics revision. And here we're looking at F equals ma, so Newton's second law. And here's a calculation with F equals ma. Before we do the calculation, I'm sure you've all watched the video on F equals ma that we made the other day with my class, and gives you the concept behind it. But remember, with force is a vector, so we put an arrow there. Acceleration is a vector, we put an arrow there. And mass is scalar. It only has magnitude, whereas the other two have magnitude plus direction. Now, the idea behind Newton's second law is that objects will only accelerate when there is an unbalanced force on them. Okay, so for example, let's just say we have a box, and that box is sitting on a bench, just stationary at rest. So if I was to apply a force to that box with my hand, I could be applying a force to that box and that box would have no motion. It would be stationary. Let's say the box weighed 10 kilograms, right? So quite a heavy box. So you'd have to put a bit of force behind it to make it move. So if I applied a force in that direction, there is a force acting in the opposite direction there, and so that is the force of friction. So we put a little lowercase f to indicate friction, and this is the applied force, so we'll put an A there to represent it's the applied force. So we've got two forces that are opposing each other, and because the friction force is a lot bigger than the applied force, the box is not moving. So in other words, I'm applying a force, but it's not big enough to overcome the friction and cause the box to accelerate. So there will be a point though where the forces are balanced and the force of friction is exactly equal to the force of applied force, and there will still be no motion, but the moment I add a little bit of extra force greater than the force of friction, it starts to move. And that's when we have an unbalanced force. So unbalanced forces causes acceleration, okay? That's the first thing to realize with Newton's second law. The second thing to realize, the second thing about the second law, bad joke, is that it's the sum of the forces. So that little sigma symbol, which you see sometimes, it's the sum of the forces. So it's all the forces in a particular direction. So if we just look at this here, remember when we said we talk about motion, we have to give it coordinates. We have to say what direction it's going, because vectors need a direction. So if I'm saying that this is along, the x-axis, because we all know maths has got an x-axis, and this is the y-axis, up and down, then at the moment there's forces acting on this box. And since the box is not flying up in the air or being pulled down through a table, we know that the forces in the y direction must be equaling 0. To begin with, when the box is stationary, the forces are 0 because it's not moving left or right, just staying where it is. However, I just said a moment ago that I'm applying a force that way and it's got a frictional force that way. So the sum of the forces in the x direction, the sum of the forces in the x direction is equal to mass times acceleration. Okay? And when those forces are unbalanced, that mass will accelerate. That's basically what we're saying here. So let me give you an example before we delve into that problem there. Let's say I have a box and I was to apply a force of 10 newtons here, and there was another force pushing in that direction and it was 8 newtons. If I was to ask you, well, what's the net force? Well, you've got 10 going that way, you've got 8 going that way. So if I was to sum all the forces in this here, then I would have 10 going that way, and we're going to call going towards the right positive, right? Because in mathematics, that's positive and that's a negative, so that would be plus 1, plus 2, plus 3, plus 4. This would be minus 1, minus 2, minus 3, etc., right? So we're going to say forces towards the right are positive and forces towards the left are negative. So this is going towards the right, so it's positive 10. And we're going to add to that this other force here, 8, but because it's going in the negative direction, we put a little negative there. And so 10 take away 8 is 2 newtons. So that is the mathematical way of writing it, but you know yourself. If I was just to say 10 force newtons that way, 8 newtons, what's going to happen? You're going to say, oh, it's going to go towards the right by 2 newtons. Yeah, you're right. See? So we know this already just from everyday examples, right? If I have another box, we like boxes in physics. So we have another box, and this time here I'm applying a force of, let's say, 100 newtons, and this one I'm only applying 5 newtons. What's going to happen? Well, same in this situation here, you've got a lot more force going towards the right, so the box is going to accelerate in that direction, but you have to take 5 away from 100, so it's going to be going in that direction, and the resultant force, that is the force at the end, is going to be 95 newtons towards the right. Right? So that's exactly what we're talking about here. We're summing the forces together, we're adding the forces together, but we have to take into consideration their direction. And that's why we have a minus, because it's going in the minus direction. So Newton's second law takes all of that into consideration. Right? The sum of the forces is equal to mass times acceleration. So let's get to our problem now. Here we have our problem now. So let's say we have a cart of bricks, and that has a mass of 45 kilograms. And you have to push that mass. And when you push it, you apply a force, and we're going to say you're applying the force directly in the same line. And you're going to cause an acceleration. Now, what force are we going to have? 38.25 newtons of force. And you're pushing it that way. We're going to ignore any friction. So over here we talked about friction, but we're going to ignore friction. It's going to be a frictionless surface, which is nice and handy in physics when we're talking about problems. So we're going to keep it simple for the moment and ignore friction. So you've got 38.25 newtons going that way. How much does it accelerate by? Well, this is just straight substitution. So F equals ma. We know that F is 38.25. The mass is 45 times A. Well, therefore A is going to be 38.25 divided by 45. And when you do that, what do you get? Let's find it out. 38.25 divided by 45, and you get 0.85 meters per second squared. Is that our complete answer? Well, not really, because remember that's our magnitude. We need a direction. So the direction would be towards the right. Okay, if you weren't told a direction in the question in terms of left, right, etc., east, west, you'd just say towards the right. So that is how you calculate the acceleration of a cart. Let's do another question and see if we can get a better understanding of F equals ma calculations.